So let's look at the question of how to estimate population size. If you go into conservation biology, eventually you're probably going to be part of some kind of effort to estimate population size. And really, you're talking about extinction. Extinction is when n goes to 0. We're more concerned. Of greater concern is when a population goes from being normal levels to very low. Either way, very oftentimes you want to know the size of the population. But notice that n right there is in italics. But statistically, that means it's a statistical estimate. The actual number is unknowable. So if you're talking about a wild population of what almost every species you can imagine in conservation biology, it is physically impossible to know exactly how many there are, and that's never attempted. A few exceptions, maybe like California condor, they probably know exactly how many there are, but I think black-footed ferrets at one time. But really, a wild population, no, you don't even try, and it's not actually important. But it is important sometimes to get an accurate, that is, an unbiased estimate of the population size. So you can see this picture here shows a person out doing a point count for birds. So the birds are out there in this meadow here, and it's probably males singing up on territories and females not. They don't really sing much, so you're going to miss a lot of them. So she's going to be estimating population size by walking transects and counting as many birds as she can see within a certain range. Okay, so they walk a transect, you stop, you do this in a standardized way, and you do it over a certain period of time. You take a certain amount of, certain number of minutes, and then you get an estimate. You can estimate within a certain area how many individuals they are, but you cannot count every individual. So just basically, you can just forget that. And really, the more plots you have, like for example, when you measure biodiversity out there in the meadow between the two coastal and CBLS, there were 3 quadrats. So if you're going to do plant research on plants, you're going to have a lot more. You're going to have a lot of quadrats, or you're going to have a lot of line transects. So the more samples you take, the closer you get to the more accurate your estimate, or at least the more precise your estimate. It's not always necessarily more accurate, but the more precise you are. There's some real n out there that would be not in italics that we can't know. But generally, the more samples you take, the closer to n you should get, assuming your sampling is not biased in some way. But you're going to be limited in how many plots you could use. It takes a lot of time to sample birds, frogs, whatever it is. I should say, so here's the reality. I think this video here shows the reality of trying to estimate population size. First of all, you got to actually be able to see the individuals you're trying to count. Here's an example here of in the Western United States. It's a very topographically complex mountains, valleys, canyons. And here they are, this is called the aerial Idaho Fish and Game Big Game Aerial Survey. So it'd be bighorn sheep and elk. And this is a helicopter survey. And so pilot flies, you have a big glass, you're kind of in a big glass globe, and you have the counters down there. As you can look at this landscape here, and obviously you're going to be missing most of the whatever it is you're trying to estimate. So here they come up on a ridge, and you'll see the bighorn sheep running. So there you go. You count them. You're seeing them because they're running. But somewhere else in that landscape, you might have bighorn sheep that are not running. And how do so you miss those. Here we have elk out on a snowy landscape, and they're pretty easy to count in that case. But they're really easy because they stand out in the snow and they're moving. But there could be other brown blobs around somewhere in the distance that aren't moving, and you miss them. And nobody thinks they're actually going to be able to really estimate. Something else you notice here is when you go in to try to estimate population size, you move the animals. That's not true for plants, of course, although you might trample the plants in trying to count them. So it's almost like trying to see an electron. It moves when you try to do that. So you're changing the population distribution by trying to count them. So just to reiterate, what they're doing here, look at this. They're not thinking that they'll ever have even the exact number in the population, however they defined it. They're doing is they're getting an estimate. So they're going in and taking samples, and then later they'll do the statistical work it takes to estimate how many there are in the general area, and they'll have a range of error, a confidence interval. It'll be this many, we think it's this many, give or take however many, whatever the error is. This is the reality of trying to measure populations. Even in a case like, for example, penguins here in Antarctica. These are king penguins here. This is a story from a few years ago where the king penguin colony, this largest colony, dropped by 90%. How do they know that? Because they do estimates using satellite images. So this is a case, probably a best case scenario, counting an animal, numbers of an animal. And you have, thousands of these here. They stand out against the green background during the Antarctic summer. They're white with black on them. They have the white bellies. And if you look at this, they just color the landscape there. However, it's pretty obvious that you're gonna miss some or many of these birds. There's probably some white rocks out there that look like you can't distinguish from penguins from a satellite image. And even if you had drone imagery, if you use a drone, you're going to scare them. They may not move fast, but they move enough where it's hard to estimate. You may get a snapshot of them, and some overlap others. You see what I mean? This is best case scenario counting, and you couldn't even come up with them here. I'm not criticizing efforts to do this. This is the fact. Instead, what you do is you get an estimate, a statistical estimate of how much there is there, and then you have a range around that estimate, confidence interval. So to do this, what I was just talking about, everything you saw there, as you can imagine, is expensive. If you want to go get an unbiased estimate that's not on average high overestimate or on average underestimate, then you got to be prepared to have a lot of funding, because it's scientifically rigorous. It means you have to have professionals out there leading the show, and it's very time consuming. You can't just have the public doing it. You can't have volunteers out doing that. It's expensive. So here is, now I want to leave you with something here, which is just an overview. And here's the key. So if you're going to do this, if you're going to have an unbiased estimate, here's what has to be true. Over here to the left, right here, here's what has to be true. In your population, as you defined it, there's a certain number of individuals. You can't know what that number is, but those individuals are there. Now, given your methods of sampling, quadrats, line transects, helicopter surveys where you fly over them or on the strip, satellite imagery, whatever it is, here's the question. Before you go out to do the sampling, does any individual in the population have an equal chance of getting sampled? You're not going to sample them all. You're not going to see them all. But does every individual, no matter where they are, have an equal chance of being sampled? And one way to think about this is think about random sampling in humans. How do they get information on polls, for example, trying to figure out who's going to win an election? They sample people. They call them. A lot of times they call landlines. Imagine that. Who has a landline phone anymore? That's a biased estimate of a population, because those are mostly older people. That's not a representative sample. They have to account for that. If you go outside, wait for people to come outside of a movie theater or a shopping mall, and then sample them. Hey, I'd like to get your opinion on something. That's not a random sample either, because the people that go into shopping malls are also a non-representative. They not a broad representative of the population, and so on. So back to the more natural examples. Does each individual in the population have an equal chance of being surveyed? And if that's true, then you have a chance at an unbiased estimate of N, if that's true. Generally, though, that's not true. You can think about why that might be. The thing about in your population, which individuals are more likely to be seen? I mentioned, with the elk, the larger individuals that tend to run more, In some cases, males are more visible than females. In some cases, adults are more visible than young. You have the biggest problem, though, is in trying to estimate N in an unbiased way is the fact that most of the time when you go out to do your surveys, you do it along a road. You drive somewhere, you get out, and you really can't go far in. That right there means you're biased. So that, in other words, individuals that are further from the roads are less likely to be sampled. You violated this assumption over here to the left. So how do we get around that? Is typically random sampling. The problem with random sampling is this. If you were to take a random sample of wood frogs in North Woods, you might be able to do that. You could have like your ArcGIS select 20 random points and say, I'm going to go to those 20 random points no matter where they are. No matter how much greenbrier there is, and I'm going to I'm going to look for wood frogs at that spot. That would be pretty good. But what if you do this on a larger scale? You choose, say, 100 random points out here in Washington County. Some of them are going to land in places you can't go, private land, for example, or areas you don't want to go. There's tons of greenbrier, or just something about the landscape that you're not really able to get in there. In other words, it's true pretty much everywhere that individuals most likely to be sampled are those that are near roads and trails. So there's your bias right there. So in other words, can you get an unbiased estimate of most populations? And the answer is no, you cannot. You're probably thinking, then why we even bother with this? So you pretty much can't expect citizen scientists, now they're called participation scientists, the public volunteers, to be able to do that. However, what can you do? Well, the way it's usually done is instead, what you do is you do your counts, and however you do them, quadrats, line transects, whatever it is, you do those, and you come up with your, I guess you can kind of say you're pretending you're estimating N. You get your number, okay, but you do your surveys the same way every time, year after year after year. And investigators in the future can go back and replicate your results, resurvey in the same way, in the same place, same time of year. You do it over and over again. And what you do, what that's called is an index. So you can call it N if you want, but it's not really in italics. It's an index. So really, I would say probably the Fish and Game, Idaho Fish and Game here, what they usually end up with in the end is actually an index. So even if they do know how much area they sampled by helicopter, so you say, well, I know I'm confident within a certain area, I counted everybody that was there, or most of what was there. Even if they do that, in the end, they're biased. There's a bias there. I don't mean like bias like a human opinion or something like that, but I mean it's biased in that some individuals are less likely to be sampled than others for maybe for all the reasons we mentioned. But that's okay, as long as these surveys are done the same way every time, and you can replicate them, and they're well described and they're standardized. That means they follow a certain procedure, and that procedure is followed the same way every time. And you and I can look at the instructions and do the same thing. As long as that happens, then what you produce is an index. And that index should be correlated with the real N. So when the real N, the unknowable N, increases, then your index should increase. And when it decreases, your index should decrease. So if your species is headed for extinction and it's not looking good, then your index should decrease. So in the case of the penguins, here, they detected a 90% increase in satellite images. It wasn't from what they thought was a thorough count. Instead, what they did is they took samples, and from those samples, they got an estimate, what was known as a biased estimate. There was an index, and the index is dropped compared to what it was before by 90%. Sometimes to estimate population sizes of something like ungulates, deer, elk, moose, it's helpful to have, since they leave these scats, these pellets, you can go out and do pellet surveys, but you don't know how many individuals, and you find a pellet pile, how many individuals contributed to that pile. You don't know if it's the same individual pooping in different spots. See what I mean? You obviously can't estimate real population size that way. However, if you walk the same transects the same way every time and you follow the pellet index survey method every time, then if the population of that ungulate happens to be increasing over the years, you should have an increase in your index. That is, you should have a reliable, consistent increase in the number of scat piles, pellet piles. So as pellet piles, as the population increases and decreases, the number of pellet piles should increase and decrease, and you should be able to detect that. So for example, here, this is a, don't worry about what the details are. These are red deer, which is what basically elk. In Europe, they call it red deer. But you have, in this case here, they were comparing, they were doing a study looking at the effect of forest habitat on red deer numbers, and they used an index. I just wanted to give you an example of that. Here's another, probably a better example here. So it's back to wood frogs. When you go out to estimate wood frog populations, how do you do that? You cannot go walking through the woods looking for wood frogs with your net and expect to get any kind of estimate at all. Instead, what you do is you have a biased way of surveying, which is you go to where they are when they breed. Because in the spring, they all breed like this. They sound like that. And you use a certain method, which the Wisconsin Frog and Toad Survey use, and every state uses.
In response to declining populations.
And you go out there, and you go out and you don't count the number of calls you hear or the number of individuals calling you hear. Instead, it's a 0, 1, 2, 3 scale. 0 being you didn't hear anything of that species. 1 being you hear a call. Describe it here. And by the way, what I mean by standardized method, like for example, you don't go out in inclement weather because that can affect things. At some point here, yeah, calling index 1. Here we go. Here's calling index 1.
Value of 1 would be recorded under bullfrog for the following.
This is not a wood frog, it's a bullfrog.
A call index value of 2 should be recorded if calls of individuals could be distinguished, but there was some overlapping of calls. A call index value of 2 would be recorded under cricket frog for the following.
Distinguish between individuals, they overlap. Category 1,
call index value of
1
3
is they don't overlap.
Should be recorded if calls were constant, continuous, and overlapping. Individuals cannot be distinguished at this value. A call value of 3 would be recorded under chorus frog for the following. Do not, under any circumstances, walk onto private property without permission.
So there, obviously, you don't even, it's a 3 would be lots, 1 would be few, and 2 is kind of in between, and 0 is 0. And that's all you have. But you hope that for whatever species it was that you're going to say it's wood frogs, that if wood frog populations are growing, that you should have more surveys where there's 3s recorded. Okay, and if wood frog populations are decreasing, you should have fewer surveys with 3s. You can statistically analyze those data and come up and determine whether the population is increasing or decreasing, but you cannot estimate the population size itself. This is absolutely crucial to population biology, conservation biology, because these kind of data can be gathered by the public. So volunteers, we depend on volunteers. Crowdsourcing, think about iNaturalist, but our Zooniverse, but especially with birds, these big various surveys like Project Feeder Watch and the Christmas Bird Count, the Breeding Bird Survey, those are all run by volunteers. They collect vast amounts of data, but they don't get unbiased estimates. You get very biased estimates, but that doesn't matter because hopefully it doesn't matter. They have as an index. And so if the population of a particular species is increasing, you should detect that. If it's decreasing, you should be able to detect that from your data. So for example, we know using the Christmas bird count data, which is a biased survey done by the public over the holiday period, we know, for example, that populations of American black duck in some parts of the nation have decreased over the decades. We don't know how many there are, but we know they're decreasing, and they're doing better in some in other areas. So that particular result is not important. It's just an example of a published study where they were able to determine with confidence that a population was actually decreasing, and that's valuable information. So in sum, you'd like to get an unbiased estimate of N, but it's very hard to do, and it's rarely, or you have the resources and time to do it. Instead, you're pretty much stuck with an index. And an index can actually be very valuable. And anyway, that's usually all we have to be able to. So when we say a population is decreasing, where do those data come from? It probably came from an index survey. So in the next video, we'll think about what some of the problems with conserving populations, in particular when populations are of small size or are isolated. And we'll think about, well, why is that a problem?